These notes are for AP Calculus AB. This is 8.8. We'll be integrating a to the u today. Now this is the last formula in the unit. So in 8.7, we took the derivative of a to the u, which was a to the u times the natural log of a times du dx. That chain rule is always in there. When we integrate, instead of multiplying by the natural log of a, we'll divide it out. So that should seem familiar. So this is a to the u divided by the natural log of a plus c. I'm going to rewrite that exponent. Okay. Now, if you prefer to write it as 1 over natural log a times a to the u, you can do that as well. Otherwise, this is perfectly fine. So, of course, in these problems, we're looking at u for our u substitution, and that u substitution is taking the place of the term in the exponent. You'll find that this is very similar to what we did with integrating e to the u, and the formula there for integrating e to the u. So if we apply that here, we would get e to the u divided by the natural log of e, so the base, plus c. The natural log of e, remember natural log and e are inverse operations that undo one another. They leave behind the only thing left, which is the exponent 1, e to the u divided by 1 plus c. And sure enough, this was our formula when we integrated e to the u. So for our examples today, we'll just practice integrating a to the power u. So you'll want to look for the pattern of a base. Remember, a is a positive real number raised to some exponent. Don't worry about the piece out front. That should be taken care of by our u substitution. So we're going to start here with u equals cosine. The derivative, negative sine x times dx. So we have that sine x dx as our leftovers, just not the negative. So we'll multiply the negative over here. And we'll replace our sine x dx with negative du. I pulled that negative all the way to the front, and that's going to leave me with 3 to the power u. So that base will stay. The substitution is just taking place of the exponent here. So in integrating this, we'll keep that negative coefficient. Our integral is going to keep what we started with, so that 3 to the u is going to stay 3 to the u. We divide by the natural log of the base 3 and add c. To finish here, we'll just substitute cosine back in place of u. All right, and that will finish off example 1. All right, so same idea here. We have a base of 5, an exponent, and then some leftovers. So we're going to start with our u substitution for 4 minus x cubed. The derivative there, negative 3x squared dx. So we have the x squared dx, but not a negative 3 coefficient. So we'll divide the negative 3 over to the left. So now negative 1/3 du will replace x squared dx. The 2 will just stay in the problem. And really, we can factor it out of the integral along with the negative 1/3. So x squared dx is replaced by negative 1/3 du. And that's going to leave us here with 5 to the power u. So I have my negative 2/3 coefficient. Integrating 5 to the u with our formula, we get 5 to the u divided by the natural log of 5 plus c. So I can substitute back in for u. 4 minus x cubed over the natural log of 5 plus c. Now you actually have a negative 2 over 3 natural log 5 coefficient. And it's possible, if you want, you could rewrite that coefficient 3 as the exponent of 5. So 3 is the coefficient of your natural log. If you rewrote it as the exponent of 5, then an alternate answer would be negative 2 times 5 to the power 4 minus x cubed over the natural log of 5 cubed, 125 plus c. Okay, so I only have one more example for you in this set of notes. This is a definite integral. So from 1 to 4, 7 to the power root x divided by root x. So you don't really see that same pattern with something multiplying in front. It's more a division, but it's the same idea, and that's just how roots work as opposed to polynomials. So I'm still going to have a base, a positive real number raised to some variable exponent. So we're going to let u equal that square root of x. So you want to be careful here. I'm going to let u equal root x. I am not using u to replace root x here in the exponent and here in the denominator. So right now, I'm just using it here. This will be 7 to the power u. The derivative here. So what's the derivative of root x? 1 over 2 root x dx. And you'll notice that pattern, dx divided by root x, right? This little fraction here is what we have here, dx divided by root x. So that is what we have right here. So the only thing I don't have is a coefficient 1/2. So I'll multiply both sides by 2. 2 du is going to replace 1 over root x dx. So 2 du will replace these terms. That's going to leave my integral with 7 to the power u. And because I've used my u substitution, I need to change these numbers 1 and 4 to u numbers. So if u is the square root of an x value, then the square root of 4 is 2. And at the bottom, the square root of 1 is 1. So now we'll go ahead and do the integration here. Keep that coefficient 2. Integrating 7 to the u with our formula is 7 to the power u divided by the natural log of 7. No plus c because it's a definite integral. And so all I need to do now is evaluate from 1 to 2. So you'll notice I went ahead and just put the natural log 7 under the 2. So that'll be my coefficient. And now I just need to plug these numbers in here. So I have 2 over the natural log of 7. And inside, we do 7 to the power 2 minus 7 to the power 1. So 49 minus 7. And then we'll multiply it together here. 2 times 42, so we get 84 over the natural log of 7. And that is our final answer. So that's everything that you need to know for 8.8. I believe there's a little bit of review in there. but that's the last of the formulas for Unit 8.